my weekend was fairly exciting. I got, let's see, I did a lot of cleaning, had a play date for my kid on yesterday for like the first time in forever. And went to another kid's and brought him to another kid's birthday celebration on Friday. So very, very happy. Short amount of, a very happy small number of days for the past couple of days for my kid, who's basically been socially isolated because there's a pandemic going on. And now that's not the case. So very nice. Also, I beat General Radon on my first try. So, in Elden Ring. So I guess I'm good at that game, which makes me happy. Which means nothing to a lot of you and something to some of you. So, let's see. So as it stands right now, I'm planning on having the second exam next week. Now, this is your chance to tell me whether or not that's a great idea or a terrible idea. Okay, it's a no from, that's a terrible idea. All right, all right.
When would it be if it wasn't next week?
It would be April 5th.
I have 2 exams the week after.
Yeah, it is midterm. It is time for those midterms. Regardless, I mean, I will think about this. I'll also gather in the opinion for next of the next section, and I'll figure that out. By the way, if people need, I mean, let's see. Oh, we got a message in chat. The exam, excellent question. What exactly would the exam be on? The exam would be on mainly trees and recursion, or in other words, mainly trees. I'll be sending out let me go ahead and send out a practice exam right now so that you guys and all can figure out. Why do I use guys as a gender neutral term anyway? I don't know what that is. Anyway, that's just, anyway, moving on. There is a practice exam, so we can take a look at that to kind of see what the expectations for the exam will be. But it's primarily going to be via let's see, practice exam 2. Exam will be TBD, either the 29th or the 5th. Okay, and now insert document, course documents. There we go. Exam practice 2. This should be the one that we want. And this is again, a paper practice exam that's much more involved. Okay. So let's go ahead and send that out and take a brief look at it. Okay. Just to answer that question of what in the world is going to be on the exam. Okay. So, first off, there will be a page, there will be a series of questions. So this question, so first off, this actual exam, again, still on Canvas, going to be longer, but there's less coding questions on it. Okay, there's more multiple choice questions. So a lot of the exam, unlike the other exam where there were no multiple choice questions or things that could be auto-graded, there's a bunch of questions on this exam that'll be auto-graded. So when you get finished with the exam, by the way, you'll basically receive a grade and it'll say you got, and if you did well, it'll say you got a 40 out of 100 because there's a bunch of other questions that still have to be auto-graded. Okay, sorry, that can't be auto-graded, that have to be manually graded by me. So don't panic if you finish the exam and it says you have a low grade. It's just like in the other exam, you got a 0 on it initially. So All right. So, but anyway, this first question will be like, here's a bunch of scenarios. Please choose the appropriate data structure. Right here, it's choose one of. In the actual exam, I'll give you multiple choice for you to select, right? Then there will be a lot of questions like the quizzes that you took on trees, which are tree relations and vocabulary. Like, hey, please fill in the blank. This will require some possible corrections on my part, either due to misspellings. You'd be surprised how easy it is to misspell descendant, or I mean, I have trouble spelling unnecessary all the time. So so I'm not going to cast stones there. I'm just saying that if you misspell it, it may not get caught. So I will have to just simply manually grade that. So don't worry about that if it's due to a misspelling. So then some drawing questions. That will pretty much be tied in like we had on the quiz, like remove these ones. Like if I remove, so give me if I remove these nodes, it would make this tree full, right? Right. And then it's a list of different nodes that would be removed, or please state which nodes would be removed to make this tree complete, you know. But here for the practice exam, draw examples, right? Then draw the binary search tree that forms after inserting the following integers. And then on the actual exam, it's going to be, hey, here's our tree. I'm adding some items to, like, here's a tree that results from adding items. Which of the trees is the correct one, right? Previous answer, draw what happens when you remove the following. Again, on the actual exam, rather than having you draw that and upload it, I'm going to say, hey, here's the initial tree. We're removing these items. Which of the following trees is the resulting tree, right? A lot of multiple choice in that regard, so that pre-order, post-order, heaps. I'm gonna have to check if those are on there. I believe they are, but basically do the same thing for heaps. Show me what results after yeah, it's on the exam. Show me, right? Here's what is the heap after I add a bunch of items and then remove. So you notice that there's a lot of theory on that one. There's a page on Huffman coding, but again, as I mentioned, that's not going to be on the exam this semester. Okay, but please feel free to try that just so that you can understand, so you can get your understanding. So what we're going to do with the coding for trees is, while I have unrelated questions here, I have one large question on the coding question for binary search trees on the exam that's split up into two parts. Like I say, here's the overall question. Here's part one, which is writing a method that will help us for part two. Okay. So in other words, you write part one and then you call that that method in the other method, part two. It's fairly straightforward. You just have to make sure you've got, you know, if you've got your notes, it'll be good. But anyway, like, there's a lot of practice questions for coding over here. There's going to be 3 coding questions on the exam overall, which is 2 trees and 1 hash map question. So the tree questions are going to look like basically, hey, do something definitional, right? Like, tell me what, like, so definitional questions like size of the tree. Is the tree full or not, right? Tell me if 2 trees are equal to each other. There's only so many questions I can ask. With that, this one's 0 points, but it's a good practice question, and we'll go over it whenever we do go over it. One thing that I can tell you that the exam won't be asking is write a function to tell me whether or not the tree is complete. That's actually rather tricky. Okay. Okay, and then your hash map question will look something like this. Here, like count, which will be a counting question, using hash maps to count the occurrences of stuff. So if you understand the idea of using hash maps to count arbitrary things that you don't know what they are in advance, then you'll have no problem with that. Which is different than what we'll be using what we'll be doing in the cheaters Hangman, which is what I'm going to go over after this. And then the analysis is only going to be 10 points, and they're going to be questions about either the runtimes of hash tables or the runtimes of binary search trees. Okay. Again, and the same rules apply, which is that you've basically got access to all your notes. Okay. You have access to all your notes, everything on your computer, all the IDE. So hopefully that answers the question as what will be on it. I will go over this the day, probably the day before the exam, since we have the exam on Tuesday, and I'll go over it on the Monday before. Okay. So, and again, we'll figure that out, whether it's on the 29th or the 5th. I'll figure that out today. Okay. Yes.
Are you gonna do that by a poll or?
Informally. I mean, if you want. I mean, do you want me to take a show of hands? I can do that. That seems better. Would people prefer it on the 29th? Please raise your hand. And people would prefer it on the 5th? I mean, it seems about even, right? That yes, no? Informal count says about even. I don't know. Sorry?
We have an exam on the 28th for low level programming.
I have the different things on the fifth, so I'm really
Yeah, I understand. This exam isn't necessarily, I will point out this exam is not necessarily as difficult if you study. The averages in the over the past couple semesters have been very high for this exam. So all right, so let's go. I mean, if you have a very strong preference, send me an email and I will figure out that way. If you care enough to send me an email, I'll take that into account a bit more strongly. So I'm going to talk about the homework, which will be due after the exam. This homework will not be dropped. You are welcome. It says work with another person. That just means that you don't actually have to. What I'm saying about that one is that you are welcome to work on this and with another person and turn in the exact same code as somebody else. Okay, for this assignment. If you do so, please put in the comments who you worked with. Okay, so and this is because I just want to emphasize that you can work on this one together with another person. Okay, and if you prefer not to deal with that kind of stuff, then do it by yourself. It's fine. So Hangman is an interesting game. I believe that's the name of the video. Yeah, Hangman is a weird game, is what. And part of that is because it's the analysis of an asymmetric adversarial pencil and paper word guessing game. Because okay, so does everybody know Hangman? Because if you're coming from a country like, if you grew up in like China or Korea or Japan, you may not have played Hangman, because Hangman basically relies on the Latin alphabet. And so so that one doesn't necessarily, so that's like a word game that wouldn't be played there. But the objective of Hangman is that you guess,
Play a game of Hangman.
no, we can. Hangman. Executioner who, Hangman game. The idea between Hangman is, so if you want to check Wikipedia, but let's go ahead and play a game of regular Hangman and figure out and see how to play that. Let's do 5 letters. And okay, I'm thinking of a word with 5 letters. Okay, and so you'll want to guess the letter. So guess it a letter at a time, and I'll tell you whether you're right or wrong. If you're right, I'll reveal the locations of letters. That's the way Hangman works. Okay. Yes.
B.
Okay, that was right.
Oh, sorry.
Anybody who wants to guess next. Yes.
A.
N?
A.
A. No, A was guessed. So we've got an E guessed, an A guessed. And so what we would typically have is like a little morbid gallows, and we'd be executing this guy by drawing, yeah,
V.
V. Okay,
R.
R. No, I'll draw his neck. Yes.
L.
L. No, I'll draw a leg.
And
N. Here we go. Yes.
S.
S. Yes. 7. Because I just wanted an easy, I wanted a nice, easy word that had repeats like that. So that's Hangman in a gist. But here's the thing. It relies, the principle of Hangman is, it relies off of trust. Mainly trusting me that I'm going to tell you correct information. Or that I am actually, and specifically the information that it relies on is me saying, I'm thinking of a word and not lying about that, instead of like having multiple words. Like the example I use in my document is, say we're playing a 4-letter game of Hangman, okay? And we've got G, O, A, and then blank. So we've guessed maybe E, Z, let's go with F, N, and D. Okay. And let's say that we have one guess left. Okay. That the player has one guess left. Okay. The principle behind Hangman relies on this, right? There's 2 words in this English alphabet that can end with that we could have over here, right? We could have goat, or we could have goat, or we could have goal, right? Those are our 2 possibilities. I mean, there's a third word, goad, but we know that that can't be the case because we've already guessed a D. Okay. So, and this relies off of me saying, I've got a hidden word set in my mind. Right? So if I'm thinking of goat, if you say T, you're going to win. And if you say L, you're going to lose. The program we're going to write is going to abuse that trust. And it's going to go, and if you say goat, if you say T, I'm going to say, oh, so sorry, I was thinking the word goal, you lose. And if you say L, I'm going to say, oh, too bad, I was thinking of goat. That's the way this is going to work. If you say the word is go, however, what I'm not going to do, okay, is that you're going to say T, and I'm going to say, oh, so sorry, the word is goad, because goad is impossible, right? Goad is impossible because we've already eliminated it as a word. It is that we are no longer in a reality where that's allowed, okay? This is also the principle behind the Wordle spin-off game Absurdle, which is, I'd been thinking about doing this before Absurdle came out, because I do this assignment a lot. So first off, everybody familiar with Wordle by this point? Right, Wordle is a mastermind. So for those of who aren't, Wordle is a mastermind level, it's a mastermind style game where basically you get 6 guesses, and your goal is to try and figure out what the word is by using those guesses. So here, I know that the word starts with T, and it has an E as the third letter, and then there's an R that's not in the second position, but it is somewhere else. So logically, it means an R has, for me, that means an R has to be here or here. So it's just kind of figuring, and it makes you feel really dumb because you think, you're like, why can't I think of a word? I know lots of words. I know the best words, so, but the idea here is that everybody gets the same word every day. And so you can share your results those little block, you can share these colored blocks without actually sharing the letters themselves. So for instance, we've got, maybe I could do TE. Let's see. There's nothing stopping me from saying, okay, so we know THE and then there's an R. And so at this point, we know it ends with an. So there we go. Okay, and then what I can do is I can share these results via clipboard, and you can see and those dots tell people how I did it. Okay, now Absurdle, but everybody is going to have there as the word, and the computer isn't going to cheat about that. And Absurdle abuses that trust. So the idea here is that if I do, for instance, if I start with Talon, which is one of my favorite words to start with, tells me I got them all wrong. And then if I go cruise, oh, notice that there is no, notice that there's no limit to the number of guesses because, yeah, because that's not gonna work. So Talon, cruise, plant. Let's see. All we know is that there's an R and an E somewhere in the word. Razor. Oh, there's an R at the end. Okay, that's okay. There? Do we know? No, we know can't have an E there, and I already guessed it. But anyway, random guess. Cheer. Verge. Spawn. Lucky. So blind. And what it will do is that it will just basically what it's going to be using is the same algorithm we are using to kind of just avoid guesses without necessarily giving us false information. So we know there's a there's a B in the word, and it ends with ER. That's it. So okay. So yeah, it's BER something. And we know it has a and we know it has none of these letters that are in black in it, which apparently, and let's go ahead and do this. Ember. Okay, that makes sense. So it goes and so don't actually give up. And if I go for Ember, let's see, is that the only? Yes. Okay. But here we go. If I were to guess Ember again, it's not going to give it to me. It's going to say I'm all wrong. Because what it's doing is that it's dodging my guesses. It's saying, what's the longest and basically what it's doing is it's trying to prolong this game for as long as possible. Prove, apple, throat, row, tacos. So many words with T, right? Okay, we found an I, right? Is the point. So here I'm going to give up at this point. It says dizzy. Don't actually give up. Give up. Ninny. Give up. Kinky. Give up. And so what it's doing over here is that it is not actually committed to one word. It's got a list of words. It's got a whole list of words. That's just having in the back of its mind saying that as to what we're going to do. So I'm going to demonstrate this via Hangman, but if you'd prefer to make a clone of this game, Absurdle, feel free instead of doing Hangman, because the principles are going to be the same. The main objectives are going to be the same, okay? So if you prefer that, you can. But let's go ahead and see how this kind of algorithm works with Hangman. So again, I'm going to go ahead and going to do a bunch of 4-letter words. And before we get started, I need to let you know all about the Scunthorpe problem, okay? Which is that we are going to be using an entire, for this contrived example, I'm going to be using a subset of the dictionary. But when we actually use the dictionary, because you'll be using a dictionary file for this. You will be encountering you basically have to use either all the words in the dictionary, or you're going to be encountering the Scunthorpe problem. Now, with Wordle, the actual game Wordle, they avoid that by removing any problematic words. But there are words that are kind of problematic, right? There's a number of 4-letter words that are very impolite to say, right, in the English language. So unless you actually go through and actually remove them from your dictionary file, there's a possibility those words might show up. So just heads up there, okay? Right? And that can be easily avoided by just not using 4-letter words and sticking to 8 letters, by the way. So just, but I just should let you know. And part of that, and I want to bring up this problem because it's a good time to bring it up, because it's called the Scunthorpe problem. And the idea here is that it's very hard to like censor these kind of word lists in the English language, because you get false positives like crazy. Okay, so basically it contains a string or basically you've got a string, it contains a string or substring that has a word in it that is obscene or otherwise an unacceptable meaning. So you can figure that out with Scunthorpe on your own, but basically that is where the idea here is that AOL prevented the town of Scunthorpe, Lincolnshire, from creating accounts on AOL. So another instance of this is trying to register shitakemushrooms.com, and that was blocked because of a substring. Okay. Same with Montreal Urban Community. Craig Coburn wasn't able to register his name because his name has an unfortunate substring. You know, Natalie Weiner. Yeah, I know, it's pretty funny when you think about it. But like, but more mundane examples, Super Bowl XXX being blocked by school web filtering, you know, stuff. So there's a number of things where we get this just kind of by accident. So let's see, I'm just trying to find, there was a couple of ones that were oh yeah. Problems occur in socialism, socialist, and specialist because they contain the substring Cialis. So if you are trying, and this one's actually a real problem with like resumes and stuff. Like if you say, hey, my position was a specialist, and the spam filter says, ah, Cialis, that's spam. That's a real problem. Like, because you don't want to get spam in your resume output, in your resume and stuff, and your resume emails. You don't want to have to wade through that. But at the same time, you don't want to actually like block people from actually applying. This is an actual problem, okay? And there's not really a good solution to this other than like, you know, trying to like code around those exceptions. Let's see. So there are things like that, and it's just it's an amusing problem, but it's also a real problem. And it's just that words are tough, and trying to filter words is tough. Okay, and it's one thing if you're, you know, and it's one thing like if you're like playing a video game and you're preventing like, you know, certain usernames or character names in your your player characters and stuff, that kind of thing. It's perfectly acceptable to be like overly broad, right? But like when you're taking in job applications, that like can have real life impacts and stuff. That's tough. And so really it also depends on the context here. And for me, like rather than going through and removing all the you know, all the words that might be problematic in the Word file, one, I'm lazy, but two, also I like to use the time to illustrate that there's an actual like issue that has to be addressed in programming occasionally. So anyway, let's go ahead and assume though that those words don't exist. Instead, we're going to go ahead and like I'm gonna assume like maybe their only letters in the English language are crow and eats and heap. I can use data structure words. Tree. That's like it's just a happy coincidence, right? List. And let's go ahead and go with reap, just because that is very similar to another word. And ball, and one more word with E. Node. Okay. So we've got basically, this is all the 4-letter words in the English language as far as the program is concerned. So let's play Hangman again. And this time what we're going to do is that we are going to guess. So go ahead and guess a letter. Okay, and now I'll show you the decision process that's going to happen underneath this. So what letter do we want to guess? Go ahead and guess any letter. It doesn't really matter in this case. E. Okay, so what we have to do is that the computer has to do is now figure out what the different realities are going to be based off of what information I give you. Because what information I give you, right or wrong, is going to determine what words I can use in the future. Right? If I tell you there's an E in the word, I can't then tell you that crow was the thing I was thinking about. Okay. Likewise, if I tell you that the word has 2 E's, I can't go back and tell you the word is keep. Right? So because it's not just the letter that matters, but the location of the letters. So what we do is we figure out what we call the word family for the term. So we take in all these words and all the guesses that we've made so far, which is just the E. And then we go ahead and figure out what families everything is in. And the family is what would be revealed based on all these guesses. So with crow, only E's been guessed. So what we would reveal if the word was crow is a bunch of blanks, right? 4 blanks and crow. Eats would be E blank, blank, blank. Make sense? Heap and reap, I won't go in order, but heap and reap would be blank E blank, blank. Heap and reap. These are, and this is because heap and reap and eats have an E in a different location. Likewise, tree and node have their own family. And then finally, list and ball go into the this family of blank, 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 of having all blanks. So this entire data structure that I just wrote down over here, so this is a data structure, which I just wrote down here. Specifically, it is a hash map where the key is the string that would be revealed to the user. And the value is the list of all words that would fit that string. Okay? So I've split everything into word families. Make sense to everybody? So now what I'm going to do is I'm going to, I now have to choose which of these families I want. And you could go like, okay, which one has the most esoteric letters? Like which ones have the X's and the most X's and Z's in them? But honestly, the simplest and easiest strategy is just to choose the biggest one, which is what Absurdle does, by the way. So I'm going to say, so I'm going to choose this word family, which means that I will say, no, you got it wrong, because this one just happens to be the biggest. And now I'll only have 3 letters, sorry, 3 words. So this is gone, gone. So it cuts down quite a bit, but let's say our So let's say the next thing that the user guesses is L, okay? Sorry. Okay. So let's go ahead and say next thing the user guesses is L. Actually, not L, but A. A would be much, because I don't have to break ties if I guess A. Okay, if the user guesses A, so they've guessed E, they've guessed A, we need to now go and make word families for these three letters. Oh, sorry, for these. So crow, E and A, so blank, 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 blank for crow. Same thing for list. List ends up over here. But ball would be blank A, blank, blank, right? Makes sense? And so I'll select the biggest word family and tell the user if he's wrong again, and just go and remove ball from my list of words. Okay, makes sense? And now let's say they guess L. Now I've got two words this list the same size, so I'll just essentially choose whatever the algorithm says how we break ties, which is up to you. But everybody see how it kind of narrows it down? So now to help you out here, I'm going to help you organize this into 4 functions, okay? So there's there's 4 functions we'll need to write as part of doing this. The first is just your initialization, which is creating your word lists. Okay, and so this is even before we play the game. This is public, static, and this is going to be a map of, this one's a weird one, integer to list of string, or it looks weird at first, but it will make sense in just a second. Create word lists. In it. So what this is going to do is basically given you can either give it a file or you don't have to, but basically what this is going to do is that this is going to do the file reading portion of it. And what it's going to do is that it's going to create a bunch of lists of words. Specifically, hash map. Let me just make sure that it compiles, return word lists. Specifically, what we're looking at over here is that the key, if I give it 5, it's going to give me the list of all words that are 5 letters. If I give it, the key 7 would give me all 7-letter words. Make sense? So this basically categorizes each word in the dictionary by their word length. Make sense? So, and that's just simply because if you're doing Hangman, you're going to basically ask them, hey, how big of a word do you want? Okay, do you want to do a 5-letter word? Do you want 8? Do you want 20-letter words? Okay, so basically you ask them how big of a word and how many guesses they want to do. How many guesses before they lose. Now, the next thing we're going to do, while you're playing the game, and so you're going to implement the game, and while they're playing the game, they're going to eventually guess a letter. And so we're going to have to do that process, that word family process that I was just doing. So, and that's going to involve 2 functions, okay, which is creating the word families and figuring out what family of words in. So the first thing, public, static, creating word family, that is going to give us, the word families are going to be stored in a map, a string to a list of other strings. Basically, remember, the string here is what gets revealed to the user if we were to go with this family. And the value is the list of all the words that belong to that family, right? So that was all the stuff, right? The word family in this case was, right, this was the key. Sorry. This was the key, and this was the value in that case. Okay. Now, create word families is going to take in it only needs to take in two things: a list of words, basically all the words that are currently still valid as possibilities, and then all the guesses that the player has made so far, which you can put in however you want, but I'm going to do that as a set of characters. Right? The reason for a set is because when a user guesses a letter for a set, you can very easily tell whether or not it's in the set, right? So you can keep re-asking them and saying, hey, that's a invalid guess. So, okay. And then again, what we do here is we are just going to create the variable and return it. Word families. New hash map, return word families. Now this one is going to be reliant on another function. We didn't have to make it a separate function over here, but I find that breaking it down like this for the students really helps. Given a string and the guesses, we want to figure out what family that belongs to. So public static string find word family, which is given a string, a specific word, and the set of characters that have been guessed so far. And string family is equal to. And so how does this work? Well, what you do is you go through the word and you ask basically, has this letter been guessed? If so, then add that letter to family, otherwise add an underscore to family. Basically, you're saying, hey, if it's been guessed, reveal the letter, otherwise keep it blank. And finally, once you create all those families, and this is what will this is where basically the, where your program may differ from other people's. This is where basically, how's it going to cheat? Because it's got to use the word family strategy. Just won't work without it. Public static string get best family. This will figure out which of the families is the best. So given, let's see, given the word families, figure out which one is the best one. String, figure out which key is the best. And for my algorithm, what I suggest is choosing the largest one. Okay, choosing the largest word. Sorry, not the largest word, but the largest family. The family with the most items in it. Okay. Another one's the one with the biggest associated list. Now, how can I confirm that this is working? I've actually got a very pretty, I've played this a number of times, so I know I have a very good way of knowing how this works. So so the way this typically plays, okay, and I'll put this back on the screen. I'll put it back on the screen in a second. Is that if I've got an 8-letter word, 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8. This is how I'll typically test your program if you're using the strategy that I lay out in the document and the one I've been talking about. First thing I'll guess is E, and the program will tell me that's wrong. And this is on an 8-letter word. Okay. This will specifically work for 8-letter words. Then I'll guess A. It'll tell me I'm wrong. Then I'll guess I, and it'll tell me I'm right. Okay, now why will it tell me I'm right? Because there's a lot of 8-letter words that end with ION and ING. Make sense? So the next thing I'll guess is N and then G, which both of those in that order will reveal an N and a G, because there's a lot more words that end with ION and ING, but there's a lot of more words than with ING than ION. And then from there, so if EAING reveals this, then it's cheating correctly. And so from there, you can get weird words like muffling or you'd be surprised how many words there are that fit this category. So I know I've spent about 15 minutes talking today, which is a lot more than I normally talk, but I wanted to go over this homework. I wanted to go over a bit of the practice exam. I wanted to make sure that everybody was prepared for this. So let me go back to this one, right? So you've got, again, 4 functions. You've got one to create the word list, which is just run at the beginning of the program to create your initial word lists. And the idea here is that we create new word lists with word families, we trim them down, and then basically the word list will get smaller and smaller based on what family we choose. Eventually you might corner it, but by that time the users probably run out of guesses. And again, you feel free to write basically an Absurdle clone, but if you do so, please make it so that it's just not 5 letters. You can make it an arbitrary number of letters. Okay? Because I think Absurdle might be a bit trickier because of that information you'd have to provide about missed guesses, letters in the wrong position and stuff like that. But the way I would handle that is because displaying color could be tricky on text, which you could do. You could probably figure out a way to print color, but I would abuse the fact that there are uppercase and lowercase letters. And I would use like uppercase for hey, the letter is in the correct position. And this letter is in the correct position, and a lowercase letter to say, you guessed this letter, it is in the wrong position, but it is in this word. Make sense? So that's one way you could handle that without resorting to colors. All right, so demos, test corrections, et cetera, I'll go ahead and take them.